Hello class, this is a Calculus 2 video. Okay, so I just want to go over 6 problems finding derivatives. Don't forget to look at my lesson plan as well. I think it's on a class email, so that way you can see other problems as well. So let's take a look at these problems. Number 1, we want to find the derivative of f of x equals 8 times the sine of 5x. So this 8 is just a constant. So I'm going to pull that out when I take the derivative. So here goes. I'm going to write f prime of x is equal to, pull out the 8, and that's going to get multiplied by the derivative of the sine of this angle. So the derivative of the sine of an angle is the cosine of the angle, and then by the chain rule, times the derivative of the angle. So the derivative of sine 5x is going to be cosine 5x, and then times the derivative of the 5x, which is 5. Simplifying, I get f prime of x is going to equal, the 5 times the 8 is 40, times the cosine of 5x. So this 5x is the argument of cosine. Is 40 times the cosine of 5x. If you want, you can put parentheses around the argument just to be real clear. That's optional. I'll do it lightly. Okay, so that's it. We're done with our first answer. It's 40 times the cosine of 5x. That is the derivative. Okay, number 2, we want to find the derivative of the cosine of this argument or angle, the cosine of the square root of x. So before I find f prime, let me simplify f so the derivative is more friendly. So I'm going to call this the cosine of x to the 1/2 power, because square root means 1/2 power. So this is still f. I brought down the equal sign. So now I'm ready to take a derivative because it's more derivative friendly. And the plan is this. The derivative of the cosine of an angle is going to be negative sine of the angle times the derivative of the angle. So f prime of x is going to equal negative the sine of the argument, x to the 1/2, times the derivative of the argument. So the derivative of x to the 1/2 by the power rule is 1/2 x to the negative 1/2. Okay, let me simplify that. So this is going to equal negative the sine of x to the 1/2, that will be on top. So I've got negative the sine of x to the 1/2 over, so this 1/2 means 2 is in the denominator. So in the denominator, I'm going to write the 2, and then x to the negative 1/2 is going to go into the denominator as x to the 1/2. Or I could write square root of x, it doesn't matter. X to the 1/2. Since my original problem used square roots, I'm just going to go back to that form. So my final answer I'm going to write like this. Negative the sine of the square root of x over 2 times the square root of x. It might be tempting to cancel these square root of x's, but you cannot, because this is not just a square root of x factor. This is the argument of the sine. So this goes together. It's sacred. So you cannot cancel the square roots there. Okay, so this is my final answer. I'll put a box around it. Okay. Here's the next problem. I want to find the derivative, and this is a product, x squared times cosine x. So I need the product rule here. So let's write f prime of x is equal to, trying to get it more clear here. So the product rule, the way I do it is first times derivative of the second plus second times derivative of the first. So I'm going to write x squared times the derivative of cosine x is negative sine x. So when you take your test, your final, rather, you can have all these rules written down in advance to save time. So I got the first times the derivative of the second. Notice the argument is just x, and the derivative of x is 1. So that's why you don't have to bother with the chain rule there. So first times the derivative of the second plus the second, which is cosine x, times the derivative of the first. What's the derivative of x squared? 2x. Okay, so let me simplify this. I'm going to write f prime of x equals, I'm going to put the negative here in front. Let me just, so I'm going to write negative x squared sine x for the first term. Negative x squared sine x plus, and here again, you can't go x times 2x is 2x squared. This x is the argument of cosine, is sacred. It's the cosine of x is one factor times 2x. So I'm going to put the 2x in front. It looks nicer that way. So I'm going to write plus 2x cosine x. And that's it. Done with that problem. So we needed the product rule for number 3. For number 4, we're going to need the quotient rule because I see this fractional bar which indicates division. So this is the cosine of x. Let me make that x a little better. Okay, so I got the cosine of x over x squared plus 1. It looks like I'm ready to do the derivative right now. Let me just draw a dividing line here. Okay, so here we go. Let's just jump into the derivative. It cannot be simplified. So f prime of x equals, and here's the quotient rule. It's low d high minus high d low all over low squared. So low is the x squared plus 1. And don't forget the parentheses. It's all of the low, or all of the denominator. So it's low, all of it, d high. What's the derivative of cosine x? It's negative sine x. So there's my low d high minus low d high minus high is just cosine x times the derivative of the denominator, d low. It's just going to be 2x plus 0, which is just 2x. And that's going to be all over the denominator squared. X squared plus 1 squared. Now here's a temptation to cancel this with one of these. But you cannot cancel these factors. Why? Because of that minus sign. This whole thing is a term. You can never cancel terms. So in this situation, you want to simplify the numerator. Keep the denominator in factored form. So this is now going to equal, when I distribute the negative sine x with these two terms, negative sine x times x squared, I'm going to write that as negative x squared sine x. Negative x squared, because the negative x squared times the sine of x. And then minus sine x times a plus 1 is just going to be a minus sine x. Plus, let's see. So my quotient rule is low d high minus. That's a minus sign. Sorry, it looked like a plus for some reason. So make sure you write minus. So I got my low d high minus high d low all over low squared. We're simplifying the numerator. So you always simplify the numerator with the quotient rule. Don't fall into that trap of canceling when you shouldn't be. So we got negative x squared sine x minus, and here again you cannot go x times 2x is 2x squared. It's the cosine x times the 2x. So I'm going to put the 2x in front just to avoid any confusion. So I'm going to write minus 2x cosine x. Minus 2x cosine x. And here again, that's all over x squared plus 1 squared. And now let's look for like terms. Do we have any like terms in the numerator? This is called an x squared sine x term. This is a sine x term. This is an x cosine x term. There's no like terms. So I would just leave that as my final answer. That's my final answer right there. Put a little block. Done with that problem. Okay, let's go to number 5. So when I see this problem, the first thing I'm going to do is get rid of the square root. So let's still keep f of x, but now think of it as cosine x plus the sine of x, all raised to the 1/2 power. If this were a cube root, I would write 1/3 power. Okay, now that I have it simplified, let's take the derivative. So f prime of x is going to equal, and you know what I'm going to do here? This is like a composite function. You got an inside part and an outside part. So that means the chain rule gets involved. So here's how we're going to do this. You bring the power down, keep the base exactly as you see it, cosine x plus sine x. And then the power is now going to be decreased by 1, so it's going to be negative 1/2. And then by the chain rule, you got to go times the derivative of the inside. So the derivative of cos x plus sine x. You just go term by term, the sum rule. So the derivative of cosine x is negative sine x, plus the derivative of sine x is just cosine x. Okay, I'm going to simplify that. So on the top, I've got the 1. This whole base is to a negative power, so I'm going to bring it downstairs. So really, I just have 1 times this expression here. So that's just going to be what I see, negative sine x plus cosine x. So that's my numerator, negative sine x plus cosine x. By the way, I got the cranberries playing in the background. Hopefully it's not too loud, but just loud enough where you can hear it. It's one of my favorite groups, the Cranberries. Okay, over, and then the 2 is going to be downstairs, and then this whole base to the negative power is going to come downstairs as to the positive 1/2. So instead of writing positive 1/2 power, that's the same thing as square root. So I'm going to write square root because my original function was in square root. It looks nicer that way. So I get cosine x plus sine x. And that is it. You brought down the 1/2, got that, negative 1/2, derivative of the inside, negative sine x plus cosine x, simplifying, this stays on top. I could have written this as cosine x minus sine x, same thing. So either negative sine x plus cosine x or cosine x minus sine x, same thing. And then downstairs is going to be the 2, and then this negative exponent comes down as a positive 1/2, which I chose to write as a square root. And that's as far as it goes. Okay, and now for our last problem. Let me separate this a little bit. So this one is going to go quickly. I'll do it over here. So I want to find f prime of x. F prime of x equals. So whenever you want to find the derivative of e to a power, it's going to be exactly what you see, e to the power. And then by the chain rule, you got to go times the derivative of the power. So I got e to the tan x plus secant x. So this is going to be my derivative. The derivative of e to a power is e to the power times the derivative of the power. The derivative of tan x is secant squared x. So, you should have that written down before you take your final so you can see it, see these formulas. Plus, because the derivative of a sum, you just use the sum rule. It's the sum of the derivatives. The derivative of secant x is secant x tan x. Secant x, let me just write this down. Tan x. Okay. So there it is. There's my original function, f of x equals e to the tan x plus secant x power, and then the derivative is going to be e to the tan x plus secant x times the derivative of the power, and the derivative of tan x is the secant squared x, plus the derivative of the secant x is secant x tan x. And that's it. We're done. We're done. So before I close off, let's just take a look at everything so you can see again. So to review, f of x is equal to 8 times the sine of 5x, the derivative, denoted f prime of x, You pull out the 8, and the derivative of the cosine of an angle is the cosine of the angle times the derivative of the angle. And then 8 times 5 is 40. So there is the first problem. And then the second problem, we've got f of x equals cosine square root of x. Whenever you see radicals of any kind, use a exponent instead. So let's call that cosine of x to the 1/2. Still f. Now I'm ready to write f prime of x. And the derivative of the cosine of an angle, think of x to the 1/2. Think of this x to the 1/2. That's your input. It's your angle. It's your argument. So the derivative of the cosine of an angle is minus sine of the angle, and then by the chain rule, times the derivative of the angle. And the derivative of x to the 1/2 is 1/2 x to the negative 1/2. And then I just simplified. Okay, so there we go for number 2. Take a nice long look at that. Make sure it looks kosher. Okay, and then number 3. You notice a product, x squared times cosine x, so we use the product rule to find the derivative. First times the derivative of the second, plus second times the derivative of the first. And then I just put the negative sign in front. So this negative, it looks nicer in front. Okay, plus, and then I think it looks better when the trig functions are at the end, so that way there's no confusion about the argument. The argument of cosine x is just x. So I like the 2x in front. Okay, so there is my answer. Notice how I have f prime of x equals. You want to label what you're doing. Okay, number 4, to review, you see a quotient, so you should think quotient rule. Remember, we're doing derivatives. So with derivatives, we have product rules and quotient rules, but not for integrals, which comes next section. Okay, so the quotient rule is, it's the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all over the denominator squared. Do not cancel. Simplify the numerator. So I'm distributing the negative sine x about these two terms to get this expression here, minus, and then I like to put the factor 2x in front of the trig function, all over that denominator squared. Done with that. And then number 5, here again I see a square root, so still f, write the 1/2 power instead. Now we're ready to take a derivative, so f prime of x equals, and then you bring down this exponent, keep the base exactly as it is, decrease by 1. What's 1/2 minus 1? Negative 1/2. And then by the chain rule, times the derivative of the inside part, which is right there. And then you can simplify it. So this stays on top, negative sine x plus cosine x, but downstairs is going to be the 2, and then this expression goes downstairs because of the negative exponent. When it goes downstairs, it's to the positive 1/2 power. But positive 1/2 power is the same thing as square root. I'm going to extend that square root, make sure everything's inside that square root. Okay, and then there is number 6, which we already went over. Okay, so that is all. We are done. Here's a quick joke, very quick joke. This person's kind of in a rush. He has to catch a train, so he tells the server, can I have a stack of pancakes? Just a couple of them, actually, because I'm in a rush. 10 minutes go by, no pancakes. So the customer flags down the server and says, my gosh, how long will my pancakes be? And the server says, oh, don't worry, your pancakes will not be long. They will be round. Okay, good night, everyone.